Welcome, this is an Edexcel FP1 video. This particular video is on tangents and normals of parabolas in the Cartesian form. Okay, so what I've done here is I've sketched on this equation of the curve, which has an equation for the parabola y is equal to y squared, y squared is equal to 36x, okay? And I've put a point P on the curve, which is there, and it's got the coordinates 12 and 12 root 3. Now, in the exam, you might be asked just to work out, it might be giving you an x coordinate and it might ask you to find the y, but, you're more intelligent than that, so I'm assuming that's probably not what you want to be tested on. Okay, I'm asked to find the tangent to the curve at the point P. And what I've put at the bottom here is just the equation, the Cartesian equation for a parabola, the standard equation, okay, which is y squared equal to 4ax. Okay, so these green lines, what I've drawn on, are just the tangents. There's obviously a tangent at minus p, which is the same as p, but we've just got it as a negative coordinate, okay, so it's mirrored in the x-axis, but as I said, it doesn't really matter, okay. What we're going to be going on to today is obviously working out the tangent. Now, well, there's two ways. Okay, so now we know the x and y coordinate of P. Okay, now to find the equation of a tangent, you also need the gradient. Okay, so the gradient is obviously found by the dy dx. Now we've got y squared equals 36x. Okay. And there's nothing really that you can do with that, because, well, there is obviously, but straight away you go, oh, well, we should have y is equal to some function of x to be able to differentiate it. Well, there's two methods that you can go on to do here, and depending on how far you've got with your A-level maths, will determine which method you're likely to use, obviously. Now, the first method, the method that you'll most likely to think of, is, well, what we need is y is equal to some function of x, so we square root both sides, so therefore you'd get, y is equal to 6x, or 6 root x, sorry, so you could write it as 6x to the half, okay, and then you differentiate that, which would obviously get you, if you did dy dx, okay, so you times by the power, so you go 3 over root x, or 3x to the negative half, and then what you would do is you would sub in your value for x, okay, which we've got as 12, so 3 over root 12, and if you sub that in your calculator, 3 over root 12, you should get root 3 over 2. Okay, and that's your gradient, and then what you would do, because we want the tangent, and the gradient of the tangent has the same gradient as the curve, so just use your standard C1 equation. If y take y1 equals m brackets x take x1, so therefore you sub in your values, so y take y1 is the same as y take 12 root 3, okay, and then you put the gradient as root 3 over 2, okay, brackets x take x1, which is just 12, okay, and then you would times both sides of the equation by 2, okay, so it'd be 2y take 24 root 3, okay, and that's equal to x root 3, and then obviously you times root 3 by 12, so you get negative 12 root 3. And the standard way you would put it in is y equals mx plus c, so we're going to make y the subject, so 2y is equal to, x root 3 take plus 12 root 3. Okay, now you could divide both sides by 2 or leave it there if you wanted to. Okay, depending on which way it would ask. But that's one way of doing it, okay, and that's kind of simple. But to those of you that have done implicit differentiation in C4, or C3, sorry, C5, I don't know, later on, anyway, so this is the other method that you could do. Okay, so what we could, now to make this a little bit more obvious, you might want to rearrange this to get y squared take 36x equals 0, and you'd be asked to differentiate that. Or you could just differentiate like this, so you differentiate each term, okay, so this becomes 2y, and you have to put dy dx next to that, remember, because of the chain rule, and then you differentiate 36x, which just gets you 36. Okay, and then you divide both sides by 2y, so dy dx equals 36 over 2y. So therefore it's 36 over 2 times y being 12 root 3. So it'd just be 24 root 3. And you sub that in, you would get root 3 over 2, as we did with the other gradient, okay, with the other way of working it out. And then, because that's equal to m, the gradient, you know x equals 12, y is equal to 12 root 3. Just sub it in, as we just did, to y take y1 equals m brackets x take x1, and work it out, okay? Now, I've asked for the tangent here. Calling on some other parts of your C1 knowledge, you may be asked to work out or calculate the normal. And just remember, the gradient of the normal is the gradient of the negative reciprocal at that point. Okay? Now, I've said P has the coordinates 12 and 12 root 3. Okay? If you were just told that P had an x coordinate 12, then you would have to find out the equation of the tangents at both points, okay? Then obviously, you would have to put plus or minus 12 root 3, because let's work it out as if we just knew 12, okay? So we knew x was 12, so we would put it into the y equation, so y squared is equal to 36 times 12, so therefore y squared is equal to, I think, 432. I just remember because I did this last time, I'm not that much of a genius. Okay, and then you square root that and you get y to be plus or minus 12 root 3. Okay, so then you would sub that into the equation for the, as we worked it out. You would work it out in the same way in terms of subbing it into the gradient equation. Okay, and you would obviously get a different gradient, you just get the negative version of the gradient. Okay, and sub it in as normal. Now these two tangents would intersect along the x-axis because they are. They're not parallel, they're going to intersect at some point, okay? So, as I said, hopefully that made sense. I did try and make this video quite quick because there's not that much to it, really. It's just being able to differentiate y squared equals whatever function it might be. So in this case we've got 36x, which there's just two methods really to sum up. You could either use implicit differentiation, which is differentiate each term, and if you were to do that, remember each y term you put dy dx next to it, okay? And see it's 2y times dy dx, okay? Then divide both sides by 2y and get the function for the gradient. Now, which function you would use depends on what you've been given. If you're lazy enough to not be able to be bothered working out the other corresponding x or y coordinate which you haven't been given. Okay, so obviously, as you can see, implicit differentiation requires you to be able to have a y coordinate, and obviously just simply rearranging it and differentiating it would just require you to have a x coordinate. Okay, so that's pretty much what this question is asking. Okay, so I think that's about it. Okay, so if there's any other questions or if you want me to do something similar to this again, please do let me know. But I think really it's just a case of you attempted similar questions to this. So as I said, if you want me to, I'll label some more in the comments if you want me to, and I will obviously do some extra videos covering them. But if you get that, that's the main thing, you know, with general videos. Okay, so I tried to make this video a little bit short because I'm trying to shorten my videos down. But as I said, if it's working against you, then please do let me know, and I'll start talking for another half an hour. Although I assume the response will be absolute zero. Physics. Anyway, so I'll shut up before I start saying something random. So it hasn't happened already. Okay, so thanks for watching. And as I said, it's really just a case of being able to differentiate y squared terms, really, and applying your C1 knowledge. Okay. So the next video we're going to move on to is, next topic we're going to move on to is finding the tangents and normals of parametric curves. Okay, so we'll see you then. Thanks for watching. See you soon.